Okay, we're going to go through a net present value example problem. So I'm going to do this with the tables, which is the long method. It is the method that the book uses, but then I'll also show you the function in Excel, which is substantially quicker. But so this says 2 local manufacturers of equipment is being considered as a source of equipment for this company. We got the Puro equipment and Briggs equipment. The after-tax cash inflows for the 2 competing projects are as follows. So year 1 for Puro is 320, year 2 is 280, 3 is 240, so on. Year 1 for Briggs is 120 for it's a 120 for year 2, 320 for year 3, and so on and so forth. But what it's asking us to do is, says both projects require an initial investment of $560,000. Assume the equipment has a life of 5 years, no salvage value. And it says assume a discount rate of 12% and compute the net present value of each piece of equipment. So the net present value means that I want to know what the value of $320,000 is discounted back at a rate of 12%, a discount rate, what the value of that is today. I want to know what $280,000 2 years from now discounted back to present value, what $240,000 is 3 years from now discounted back at a rate of 12% today, and so on and so forth. So effectively, I need to take each and every one of these numbers and discount them back to what the present value is. I also need to take into account my year 0. My year 0 is the initial cost, the initial investment. And these are all cash inflows, money coming in, which is why they're positive numbers. My cost in the first place is money going out, so that will be a negative number. So I'm put negative 560,000 for each of these. And remember, the whole idea here is that I need to figure out a way to discount these back to the present day values, based on the fact they all differ in amounts and they all differ in timing, year 1, 2, 3, 4, 5. So one method for that is using the tables. So I want to figure out what the value of $320,000 is discounted back at a rate of 12% to this year. So if I go use the present value table, the present value of a single amount table, I can go, my discount factor is 12. And so year 1, I can put 0.89286 in there. 0.89286, oops, not for year 0, excuse me. That's for year 1. And if I multiply those two, then what I can say here is, if I were to receive $320,000 1 year from now, the present value of that $320,000 discounted at a rate of 12% is $285,715. And I can do that for each and every one. It's tedious, but I can. So I need to if I'm going to figure this problem out with the tables. So year 2, again, 12%, 0.79719. I'm just going to move this over to a different screen where you can't see it, but if you understand where I'm getting them from, 0.79719, and then actually I'll show you two one more time here. 0.79, so then 71178, 653552, all the way down to year 5 of 51937. So I'm going to enter all those in. 71178. 71178, 0.63. 552 and 0.56473. And you notice the numbers go down, which makes sense because if something is going to grow at a rate of 12%, or if I'm discounting backwards at a rate of 12%, then it's going to become less and less valuable the longer the time frame is. So now I'm just going to take this number times the discount factor, this number times the discount factor, this number, and so on and so forth, and find all those discount factors. I'm sorry, present values using all those discount factors. So the discount factor for year 0 is always 1.0 because it is not in the future at all. It is current. That happens up front in the project. That is present day. So the present value for that, the discount factor for that is always going to be 1. Now, the good news is, and I think they did this on purpose to save you time, is we didn't have differing discount rates for these two, which means my discount factor is going to be the same for my Briggs equipment as it was for my Puro equipment. So I don't have to go back to the table again. I can just utilize all the same ones that I just got done utilizing for the other equipment and use them again. And then I'm going to have to do the same thing, find the present value of each and every one by multiplying across. Okay, and now if I sum these, if I total these up, take including year 0 all the way down to all these present values, and that is the net present value of that Puro equipment. The same thing over here, equals sum including the present value up here, 373. And remember what this number represents. It represents how much additional cash flows above and beyond a rate of 12% these projects are going to give us. So if this number were 0, if NPV can end up being exactly 0, that means my return is exactly 12% because that's my discount rate. If this number is higher than 0, and I don't know how much, what the percentage is, but and you can figure that out, but it's a whole different method. Then I know it's above 12%. If it comes out a negative number, then it would be less than 12% return on my investment. So as you can see here, the Briggs equipment returns a higher net present value as compared to my to the Puro equipment. Now, I'm going to, just so I can make a little space here, put my discount rate over here. I'm going to show you how to do this with the NPV function in Excel. It's much quicker. I don't need to go to the tables 5 times. I don't have to multiply. It's so much simpler. So how the NPV function works in Excel is you only need 2 things. You need a group of values, that is, or 3 things, excuse me. You need a group of values, that's your cash flows. You need a discount you need discount rate, and then you need to manually subtract out the year 0 number. So let's do this in 2 steps. So I'm going to find the present value of the cash flows at a rate of 12%. At a 12% discount rate. So if I hit equals NPV, open parenthesis, rate, I'm going to use my 12%. And then I'm going to highlight, I got to start with year 1. It assumes year 1, 2, 3. So the function assumes that whatever you highlight first is year 1, not year 0, which is actually why this formula is a little weird. I would think it would have year 0 in it, but it doesn't. So I'm going to highlight year 1 through 5, close parenthesis, and hit enter. That is the present value of these numbers, 320, 280, 240, so on, discounted back to present value. But it is not the net present value, because the net present value needs to net out the initial cost. So initial cost, so the year 0 cost. So my net present value is, I could have done that in the function too, is 289,529. And you can see that it is a little off. This one is more accurate. This is the one that the book uses because it uses the tables, but this is the more accurate NPV. This is the one that the table got us. So I'm going to do the same thing over here. Do the same thing over here. But I'm going to do it all in one step to show you how that works. So NPV, so net present value, and it equals NPV, open parenthesis, rate 12%, comma value, still going to just do 1 through 5. And then I'm going to add just on the tail end that year 0 just to make sure that gets netted against it. And 374. And you can see, again, it's just a little different than this one. This is the more accurate one, but they are basically roughly the same number. And that's how you find net present value.